In today's video, we're going to be looking at domains. So I've written a couple of examples and also I've included some of the rules here so that we won't waste a lot of time trying to explain these ones. So domains are basically talking about your restrictions, or you can just keep it in mind that you're always looking for that region that makes the function breaks, or that makes the function undefined. What do I mean by that? So let's just say, for instance, for this number one, from your basic understanding of math, you know that if you have a number and below you have a zero, this it's going to be undefined. You see, so that's basically the restriction that you have to know. You know now you can't have y is equals to 1 over 0 because you can't divide the 1 by 0. This becomes undefined. That's basically the rule 1. And now we come to this one where you have your y is equals to square root of x. So with this one, what is the restriction, or what actually makes this one to be undefined? In order for this to be undefined, it's when we can have a negative number inside, like when we have, for example, minus a root of minus 3. This will give us an error if you try to punch it on your calculator. So you already know that your restriction, the only values that are going to work are going to be your values starting from 0, then 1, and so on up to your positive infinity. Hence, this is where you see this rule that they are talking about. Then now you get to your cube root. Then with your cube root, you also have to do your testing with your values. If I have my cube root of x, f of x, then I can test with a wide range of values. Like you can test from minus 3 to 3 and see what happens. If I put minus 3 here, I'm still going to be getting an output. So the main trick here is for you to be able to get your inputs, whether they are negative or positive. As long as like you're getting an answer, that means that also falls within your range. But the moment where you get something that's undefined, that's the area that you have to mark that, okay, this would be my restricted area. You see, so as I was saying with this one, if you input all the numbers, you'll actually see that the domains falls within all your values of your x, or x is the element of all real number line. Then we've explained this one. Then we get to these types where you have your ln. Remember, in calculus we are using ln of x, but in your high school and your college you were using your log of x. These are always the same. You know, if you draw your graph of ln of x or your log of x, it will always start here at point 1 being something like this. It is steep, then it starts going to be flat when it goes to the top. So with your ln and your logs, you can't have your ln of 0 and you can't have your log of 0. Your ln of 0 and your log of 0 are basically undefined. You see? So those are the key things that you have to notice. The last one, if you are given something that looks like this, you are given a square root of z and plus square root of 10 minus z. So with these types, whether the sign is positive or negative, you have to consider them separately. You solve this part and you come to this part. You still apply the same rules that we have, you see. So even the mathematician, when they came to these rules, what were they actually doing? They were trying and testing with a lot of numbers. Like they were just choosing numbers between minus infinity to positive infinity, and also including things like your factors that you see within the radicand. So the radicand, these are what we refer to as the radicand. These are the symbols or the stuff that are found within a square root. Those are the ones that we call the radicand. You see? So yeah, that's just another math for another day. So they said you should find the domain of the function and write your answer in set notation. Remember, we have the set and we have the interval. Your set, you'll always see them with your curly lines that looks like this. Your interval could be something like this, or it could be like this, or it could be a combination of this and this. It just it depends on the type of restrictions and the question that you're being asked. So now I think we've explained the basics. It's time now to go and try and do the first one. We said we have 1 over t squared minus 81. That is your number one. Then what did we say would be our restriction? Our restriction is that this bottom part should not be equals to 0. You see? So if we're saying that, how are we going to write this in terms of our answer? Remember, they've instructed us to draw it in set notation. So how you'd remember, you'd know, if you're having curly lines, you can use an example that you're going to have something like your curly hairs and so on and so on. So we have your t such that your t squared minus 81 should not be equals to 0. See? So now you can expand this as the difference of two squares. You have t minus 9 and t plus 9. This should not be equals to 0. Then your final answer, you will say you have your t such that your t should not be equals to plus or minus 9. So plus or minus 9. You know, if you're going to take this 1 and equate it to 0, you're going to get t minus 9 is equals to 0. This side, t plus 9 is equals to 0. Then you take your 9 to the other side, you're going to get this final value. You see? And also one thing to note, you see, the reason why I'm writing my t's here is that here I'm working in t's, but when I get to another one, I'm working in a's. So I see also students, sometimes they make a mistake of using x here instead of using the correct number. So also put that in mind when you are doing these ones. So now let's do example 2. Example 2, you have f of a is equals to square root of c squared minus a minus 6. So now we have to look for factors of this. So let's just now try and write it in a certain notation, certain interval. We have a such that a squared minus a minus 6 should be greater than or equals to 0. That's just our starting point. So now when we get to the second point, that would be when we are working out the factors for this. So here we still have that a, then we're going to look what factors of 6. Factors of 6, it's your 3 and 2. So now we ask ourselves, if we add this 2, in which combination will that allow us to give us -6 and also -1 or minus, yeah, this, remember, is the same as having 1. So now you can say you have your -3 and +2. If you add this, you're going to get -1. This multiplied by this is going to give you your -6. So I can come and write my -3 here, then the 2 this side. So I'm almost there. I'm just left with the last step. So the last one, you're just going to say your A. Okay, I forgot to write this line. So A is such that your A is less than or equals to -2, which is the one for this. Then you will say or A is greater than or equals to 3. So that's the 3 steps I always follow. So we're done with this one and this one. So now we go to the third one. So the third one, as I've explained, you basically don't have to write a lot because x or b, no, not x, you see I'm making the same, b is the element of all real number line. So you can just write it like your b is the element of all real number line, or you can just come and write it even here, that okay, you are having b such that your b squared minus b minus 6, then yeah, you can just write b is the element of all numbers. So yeah, I don't think there isn't any other way you can try to even write it further. So we're just going to continue with this one. So now we are given f of x, we are having ln. So now we are here, and I said this can only be undefined if you are having something like your ln of 0. So whatever that you are working with has to be greater than 0. So it means now the part that you have inside should be equated to being greater than 0. So you're going to say you have your x such that your x cubed plus your x squared minus 2x should be greater than 0. Then if you look at this one, we have, what do we have here? We have x cubed plus x squared minus 2x. This could be written in which form? This could be written like this. You can take out your x as a common factor. You will say you have x into your x squared plus your x minus 2. You see? So now that you've written this one, you can basically go and write the final equation. Remember, these ones we have to equate it to 0. So what are we going to have? We're going to have x, then we have to find the factors for that one. So for that one, we can definitely see that is going to be 2 and 1. That's 2 and 1. So it means now we have to get -2 and +1, because if you multiply this by this, you get -2. If you are adding -2 plus 1, you get no. It has to be minus 1 plus 2. So yeah, this one has to be -1. So we say if we're adding this, we're supposed to get 1 or x, then this multiplied by this is supposed to give us that minus 2. So now we've worked out in a correct way. So now we're going to group them together. Remember this, it's equals to 0. So if you solve this, you know x would be equals to 0, then we will have x is equals to 2 and also x is equals to 1. That's it. So how do we write this? We will write this one by grouping it by saying we have minus 2 is less than x is less than your 0. So that's the first portion on the left hand side. Then for the right side, we're going to say or x is greater than 1, just like I've said. See, so we have these ones that are in the left and this one that is going to be on the right. So remember, they can also ask you to interpret this in a number line, but that would be another different question. I'll try to find the ones where they say you should draw a number line. So we get to your last one, and as I said, with this ones, you do solve them separately. You consider this first one, then move to this first one. But now the only thing that you have to keep in mind is that whatever that you are having this side must also satisfy the other part, meaning the solution that you get must be satisfying your root of z and also your root of 10 minus z. So if we have this one, we know we can say we have our z is such that our z should be greater than or equals to 0. You see? So now on this other side, let me just do it like this. So we solve it in twos. So we can see what? We can say your z is such that your 10 minus z should be greater than or equals to 0. So from this one, we already know that the answer will be this, but for this, we have to at least try to solve it further. So if we're solving it further, remember, we have 10 minus z is greater than or equals to 0. So we have minus z is greater than or equals to minus 10. Now we have to change the sign convention because we don't want to work with negative. We're going to say, if we're changing this, it means now we have to divide by minus 1. And if we're dividing by minus 1, this sign in the middle is going to change. It's going to change. It's no longer going to be greater than or equals to, but now we're going to be having z it's less than or equals to 10. You see? So now that will be basically our answer. So it means for this criteria, it means, let me just check. Yeah, basically you are going to be getting your answers that are in between 0 to 10 and including 10. 0 and including 10, 0 and including 0, up to 10 and including 10. That's why you see this closed bracket. See, so it means that would be the region that satisfy the two parts. So how we write this one is that the final solution, we will say we have our z such that, let me see, okay, yeah, we have our 0 is less than or equals to z, then it's less than or equals to 10. So if you were to confirm, you'll see this answer that you got, it does satisfy this part and also this part. So we always check in between. If it doesn't, then it means that's not part of the answer. So yeah, these are some of the questions that you're going to be asked on domain. I'm just trying to think about one I can give you guys so that you can do it on your own, and you will comment with your solution. So at most you're going to get examples that looks familiar or more or less like this. So that's why I chose this for special rules. So now let's just say you have your f of x is equals to your root of t minus 2. So I would like you guys to find for me the solution for this one and comment with your answers. Then the second one, I can say you have your h of x that's equals to 1 over x plus 1. So that would be the second one. You can do 2 of these and comment with your answers, and that's basically it on the domains.